Hi. Just starting off in 2 minutes, just making sure that all the systems are go. Right. I'll wait for about 1 minute so that I can get the green signal that all the systems are live, and then we will start. I'm trying with a slightly different webcam today, so just bear with me. Okay. Just hold on for half a minute. I'll just get the green signal because I'm doing this YouTube screen share for the first time after a long time, and on doing it on a slightly different system than I usually do. So kindly bear with me. All right. So all systems are go. So let's start off. My name is Vivek. For those who know me, I work with Topmytest. I am actually collaborating with Rajesh for 2IM to create a few DILR sets for your CAT preparation this year. So I'll be presenting a series of videos on certain sets which we have created together. So these DILR sets are original sets based on CAT papers over the last 2 to 3 years. Uh, I also run a separate course for DILR, and I have some practice tests. So, in case you're interested, please go to our channel as well. Please do subscribe to 2IM's channel in case you are watching for the first time, because they have pretty awesome videos over here as well. Now, DILR over the past 3 years has become 3 or 4 years has become sort of like the in thing. Okay, it's like the new startup over the last 2 to 3 years, for the simple reason everyone seems to think that there is something completely different than what it actually was over the past few years before the system was changed. Now, according to my view, and this is my personal opinion, but I will put it with some amount of facts. The reason why DILR has suddenly become so difficult is because for a lot of time, DI used to be clubbed with maths, LR used to be clubbed with English. So all you had to do was crack maths, ignore DI completely, crack English, ignore LR completely, or the type of LR questions which used to come was slightly of the easier variety. So people used to strategize by saying, okay, I will not read English at all, or I will not do LR at all, I will not do DI at all, I will do only maths and English, and I'll crack the section. So when it switched back to the three section sort of test, which we have over the last 2 to 3 years, which is very stable now, people are facing that problem where they don't know how to do DILR again. The second difference which has come up in DILR is there is a lot of uncertainty which has come up in DILR. Unlike previous cases where you have a question with a definite set, you even tough looking sets, suddenly you had now questions with ambiguity in it. So you solve a set and then you end up not being able to get a solution and still you have to answer the questions. So people have these theories, okay, I will crack using the options, I will crack using, yes, options have always been used, options have always been required to solve the sets, there is no part. But people have become extremely smart, people who have set up cat have become extremely smart, so they have reduced the difficulty level of English, they have taken away grammar completely, fill in the blanks, vocab, etc., completely. Okay, vocab anyways was not that important, but all the grammar is gone, so you have only reading comprehension and some passage paragraph based questions. In maths the level has been dumped down to such a level that people, uh, I mean, even non-engineers are supposedly able to crack, but it was never an engineering game anyways. So what do they test you? How do they differentiate between a person who has his basics right and person who does not have his basics right? The only way to do it is the DILR section. So they have cranked up the difficulty level of the DILR sets. It is not that they have become ultra difficult. If you look at the solutions of DILR sets over the last year, which there were two slots, and CAT thankfully has presented the questions from DILR. There were 16 sets. Out of those 16 sets, 10 to 11 over the two slots are reasonably easy, reasonably moderate to do. They are not easy, but they are moderate level. There are 5 to 6 sets. The problem was, out of these 5 to 6 sets, three of them came in the first slot. So the first slot became ultra difficult for people not accustomed to that. The second thing is, if you see a type of question which you have never encountered earlier, people think that, okay, what do I do? What do I do? So thinking on your feet is very important in DILR, rather than trying to mug up different patterns. That doesn't mean that you should not. That doesn't mean that you should not prepare for DILR at all. There are a lot of things which you can do for DILR, which you'll go through in different courses that you're taking up. But the key point to remember in DILR whenever you're taking these tests is, instead of solving 5,000 questions, try to solve about 200 odd sets of decent quality and of a different variety. Even if you take about 7 or 8 topics in the ILR, so if you have optimization, if you have Venn diagrams, if you have arrangement, reasoning, whatever you want to call it, right? Different areas which are there. Try to see if you can get a different sort of a set. What will happen if this variable was removed? So you have cracked a set, great. Most people do not go back to a DILR set and understand it. The reason is very simple. DILR takes a little bit of patience. In today's world where we have very little patience to grind out things, it completely manifests itself in your scores. If you do not show patience with DILR, if you do not treat it with some amount of respect, it is going to bite you. On the other hand, if you are going to be too scared with it, it's going to bite you back, because you'll be too scared to even think. If you get a slightly different set, leave half the paper, you'll still be able to clear the section very easily. Now, if you look at the sets over the last 2 years, a lot of them, even though you cannot classify them as a DI set or as an LR set, you had conventional LR sort of sets with a lot of math involved. You had a lot of DI sets with a analytical thinking involved. A lot of ambiguity in the data. So there is no set which you can say it's purely maths based or purely reasoning based. So try to find a mix of sets which have both numbers involved as well as reasoning involved. DILR is extremely important in today's world. We are overtaken by machines every single place. I mean, you would have seen the Facebook scandal. What are they after? They are after your data, right? Everyone wants data. Mr. Ambani actually said that data is the new oil, right? So you need to understand data. But a lot of people are generating a lot of data, but in reality, not all of that data is important. I am a part of a lot of WhatsApp groups, a lot of Facebook groups on test preparation. You post a question on maths, right? People will solve it in 1 minute, right? They will give you 25 different techniques to solve it. They will say, this is my shortcut, this is ex Guruji's shortcut, this is Babaji's shortcut, and so on. On the other hand, if you post a question on, even on the WhatsApp group, on DILR, less than 10% of them actually get solved, right? Because on an average, a DILR set requires about 8 to 10 minutes to solve. And if somebody has to explain that solution to you, right, it will take you about 15-20 minutes for him to think, about half an hour to for him to actually think about how to present the solution, and another 10 to 15 minutes for you to present it, right? Nobody has that patience, either to wait for the answer or to make that part. So while a lot of people claim that they are solving DILR, what they are actually doing is basically showing that I'm going to doing DLR. It's sort of like, I have joined a gym, right? I did not visit the gym for the last 2 months. So, but I have a gym membership. So I am solving DILR. So DILR has actually become like that. Everyone claims that they are doing it, but nobody actually does it, right? And people who are doing it are just doing it because they have invested some. It's like, it's a sunk cost fallacy. The problem with DILR, and it's the same problem with your English as well, is that if you ignore it, it is going to only get worse. So suddenly in June, July, you will end up having your mocks, and then you're going to go nuts because you're not able to make head or tail out of it. And end of the day, you're going to panic, right? And panic in DILR is your worst enemy, right? So I think a lot of people have joined in now. So for people who joined in late, they can actually go ahead and review this later on the YouTube channel that we have. I will be doing two DILR sets today. Okay, they are conventional sets which are with a twist. So rather than having your normal problem which come up here, both these sets are theta based sets. None of the questions will have options in it, so you'll have to dig into it and do it. Now the aim here of this broadcast is not to show the speed at which I'm doing it, but look at different things which can come up even in simple looking sets, which can be made complex just by changing one variable, which we normally think is already given to us, right? We take that variable for granted. So if I remove that variable, what happens is what we are going to do. So I will be sharing my screen right now. Okay. So please be patient. Uh, Right. So I think the screen is available to everyone. So this is the first set over here. I think it's visible. I'll wait for about 3 to 4 minutes so that you can all have a look at it. You don't need to solve it straight away. Just have a look at the question so that we can dig into it later on and uh, solve it together. All right. So that's the end of 3.5, 4 minutes. Let's see what the question looks like. Now, obviously, this is a Venn diagram question. It says Professor Ramanujam at Prime coaching classes was evaluating the midterm results of his students. Each of the students in his class took up a test in physics, chemistry, and mathematics. The following details were observed. The number of students in the class is a two-digit prime number. Okay. So total number of students is a two-digit prime number. So you're looking at a less number which is less than or equal to 97. The number of students who passed only physics, only chemistry, only maths were all consecutive two-digit prime numbers. We'll come to this later. The number of students who passed in each combination of exactly two subjects and the number of students who passed in all the subjects are distinct single-digit prime numbers. Okay, so this is also a prime set. And the number of students who failed in all three subjects is a prime number and is more than one third of the total number of students. Okay, so let's just draw a set. This is your normal Venn diagram. Now, one biggest problem over here is it does not mention a subject by itself, right? So we don't know which subject you're talking about. It only talks about subjects as such. Like here it says only physics, only chemistry, only maths are single digit, are two-digit prime numbers. So we know it's ACG, but which out of ACG we don't know, right? This is the only thing which talks about one part in general, right? This part talks about two subjects and three subjects. So this portion, right? Besides that, we don't know anything about what is the total number of students in physics, total number of students in chemistry, total number of students in mathematics. So let's see what we actually have over here. Okay, now we know the total number of students is a two-digit prime number. So I have marked the regions A to H. So A to H will be a number which is less than or equal to 97 because 97 is the largest two-digit prime. After that, the next prime number is a three-digit number. Number of students who passed only physics, only chemistry, and only mathematics are all consecutive two-digit prime numbers. So exactly one subject, any of them, ACG. They have to be consecutive two-digit prime numbers. So you have 11, 13, 17. The next can be 13, 17, 19. The other set can be 17, 19, 23, and so on, right? So this is the situation for A, C, and G. Okay. Now, the number of students who passed in each combination of exactly two subjects and the number of students who passed in all the subjects. So it is talking about B, D, F. These are students who passed in exactly two subjects, and E, which is all three subjects. So B, D, E, F, right? We know this has to be distinct single digit prime numbers. Now there are only four single digit prime numbers, 2, 3, 5, and 7. So all these four should take one of these values distinctly. So if B takes 2, D takes 3, E takes 5, F takes 7, that is one scenario possible. Another scenario will be B takes 5, E takes 2, D takes 7, F takes 3. We don't know which one takes which one, but we know these four primes are gone with this. Okay. Again, the order is not known at all. And the last one says the number of students who failed in all three subjects is also a prime number and is more than one third of the total number of students. So H is also a prime number and it is more than one third of the total number of students. So H is more than one thirds of A to H, which means if I take H out, A should be less than half of, greater than half of this, right? A should be greater than half of rest of all this A to G, right? Let me just erase this, right? Because A is more than, H is more than one third of all of them combined, it should be more than half of the rest of the others, right? This is a very simple, very standard arithmetic trick. I'm sure you would have seen it in your arithmetic classes, right? So now, using these constraints, let me try to find out what are the maximum things that I can find out from this, right? So BDEF total, let me try with this. BDEF total will add up to 2 plus 3, 5, 5 plus 5, 10, 10 plus 7, 17. This total is 17, right? ACG, this total will be 24 plus 17, 41. This total will be, I've taken out 11, added 19. So increase by 8, 49. I have taken out 13, introduced 23. So add 10, 59, and so on, right? So if I add A to G completely, A, B, C, D, E, F, G, right? So this will be the total, right? So if I take 17 and 41, this total will be 58. H should be greater than 58 by 2, which is greater than 29. Now, the first prime after 29 is 31. If I take 58 and 31, I get 89, which is a prime number. The next prime number after 31 is 37. 58 and 37 will be 95, which is not possible. Next prime number after 37 is 41, right? 41 plus 58 is 41 plus 58 will be 99, and we have already exceeded the cap. So if this total is 41, this combined total of A to G becomes 58, which means H should be 31, right? That is one scenario possible, and the total is 89. Let's see if there is some other scenario possible, right? If I take 49, right? 49 plus 17, 49 plus 17, this will increase by 8. This will become 66, right? Half of 66 is 33. The next prime number that I have is 37. 66 plus 37 gives me 103. I have exceeded the limit. So this scenario is not possible. This scenario is not possible. So all I know is ACG is from 11 to 17. BDEF is 17. H becomes 31, and the total will become 89, right? This is all I know, right? So that's all that we have from this set. We have to now go to the questions and try to answer them based on a case-to-case basis. Let's see what we get. Okay. The first question said, if the number of students who passed in physics is a perfect cube, what is the total number of students who failed in physics but did not fail in all three subjects? So let's take this as physics. I've put total as 89. I've put H as 31, which is all three subjects. So I want people who failed in physics, right? Who's outside of physics, but did not fail in all three subjects. So we are looking at these three. What we know is the number of students who passed in physics is a perfect cube. This number is a perfect cube, right? Now, A is a two-digit number, right? A is a two-digit number, and B, E, F are all single-digit numbers. So the total number of people who passed in physics will be a two-digit number because the total itself is a two-digit number, right? So we need two-digit perfect cubes. What are the two-digit perfect cubes possible? 16 is the two-digit perfect cube. 27 is a two-digit perfect cube. 64 is a two-digit perfect cube. Right? So using these numbers, can I reach 16, 27, or 64? Now, easiest option to eliminate is 64, right? Because this adds up to 41, right? This adds up to 17. 41 plus 17 is 68. Now, if I put 64 over here, I'll be left with only 4. Now, with the remaining numbers, there is no way I can reach 4. So this is out, right? Now, 16. Can I reach 16 with these numbers, right? A itself, the minimum value is 11. Can I reach 5 with these three, right? Even if I take this lowest 3, it will be at least 10. right? So the minimum possible range for physics would be at least 21. So 16 also is not possible. So 27 is the only cube which is available. So physics is 27. Rest of the people are people who failed in all the subjects are 31. What is the leftover number? Right? So that will be 89 minus 31 minus 21. So that's 89 less 52, right? 89 less, sorry, 27, right? This is 27 and 31. So this is 58. 89 less 58 is 31, right? So 31 is your correct answer, right? So that finishes the first question. Let's go to the next one. Second one said the number of students who passed in physics, number of students who passed in chemistry, number of students who passed in maths are all prime numbers. What is the number of students who did not fail in any subject? Did not fail in any subject is E. Right. Now, remember, while these people want to make your life difficult, they still want people who observe to be able to answer the question. DI is all about observation as such, right? So people who observe should be able to answer the question. Now, what do we know about prime numbers? Except for 2, all other numbers are odd numbers. Except for 2, all other prime numbers are odd numbers. And people who passed in physics, people who passed in chemistry, people who passed in maths, this total should be a prime number, this total should be a prime number, this total should be a prime number. All these total, A, B, E, F, B, C, D, E, D, E, F, G, they should all be prime numbers, right? And the prime, in other words, they should all be odd numbers, right? Now, we don't want to find all the prime numbers. There are multiple scenarios possible, but we don't want to find those odd numbers, right? What we know is we are adding 4 numbers at a time and getting an odd number. Now, how do we add 4 numbers at a time and get an odd number? You can add 3 odd numbers plus 1 even, or you can have 1 odd number plus 3 even number. This is the only combination which will give you odd. With 4 numbers, if you add them and get an odd number, the only way out is 3 odds, 1 even, or 1 odd, 3 even. Now, because these are prime, you cannot have 3 distinct even numbers. The numbers are all distinct here, right? So this scenario is out, right? So you have 3 odd numbers and 1 even number, right? So there is 1 even number which comes up in all the 3 groups, right? This number has to come up here. This number has to come up here. This number has to come up here. Which is that number? E. E is the only number which is common among all the 3 subjects, right? And that number has to be even because that is the only even number available. So it has to be shared across all the 3 groups. So E has to be equal to 2, which is what we needed. E has to be 2, which is what we needed for this, right? So instead of trying to find out the primes over here, all you need to do is understand what is getting repeated, what is the type of number that you're looking at, and then solve the question, right? Let's see. The next question is also pretty simple once you get a hang of this. The number of students who passed in physics, the number of students who passed in chemistry, and number of students who passed in maths are 3 consecutive natural numbers in ascending order. So you have physics, chemistry, maths, right? Number of people passed in physics, that's A, B, E, F. Number of people passed in chemistry, that's B, C, D, E. Number of people passed in maths, right? They are 3 consecutive natural numbers in ascending order, right? Now, what do we know? They are one after the other, which means the sum of these 3 should be 3 times the middle number, right? Now, if this is the case, what is the number of students who passed in chemistry? Now, look at the question. It does not ask you how many people passed in physics, how many people passed in maths. It asks you what is the number of people who passed in chemistry, right? That's the middle number. That is the easiest determinable number. Let's see what we get. If we add physics, everything, suppose I take this as physics, this as chemistry, this as maths, right? So if I add number of elements in one or more sets, that will be equal to, in physics you have A, B, E, F. Chemistry you have B, C, D, E. And maths you have D, E, F, G. Right? This is chemistry, just to distinguish. Right? Now what will we get? We'll get A, C, and G comes once, B, D, F comes twice, and E comes three times. E comes in all the three ones. Right? This should be three times chemistry. Right? Now I know ACG for sure. ACG is 11, 7, 13, that is 41. BDF I don't know separately because I don't know E separately. What I can do is I can split this as 2E plus E and combine this with this. So twice of BDF, BDEF. BDEF adds up to 17. So twice of 17 plus E should be equal to 3 times chemistry. 41 plus 7, twice of 17, this is 34, plus 41, this is 75, right? So 75 plus E should be equal to 3 times chemistry. Now because of this, chemistry should be a natural number. So this divided by 3 should be chemistry, which means E should be a number such that E should be a number such that 75 plus E is divisible by 3. Now 75 is automatically divisible by 3. So E should also be divisible by 3. The only number which is divisible by 3 is 3 itself. Right? So 28 will be the number for chemistry. 75 plus 3 is 78. 78 right? 78 78, right? 78 divided by 3 will be 26. Sorry, 26. Right? E is 3. 75 plus 3 is 78. 78 divided by 3 is 26. Right? Okay. Let's go to the last one on this set. Okay. The last one in this set said if the number of students who passed in chemistry is same as the number of students who failed in all the three subjects. Okay. So let's take this as chemistry. Right? Is same as the number of students who failed in all the three subjects. So this is 31. This total is 31. Right? What is the number of students who passed in physics only or maths only? So if I make this physics, maths, so I need physics only and maths only. So I need C and G. Now chemistry has to be 31, right? Now A can take one of these three values, right? If I take 11, balance from 31 to 11, I need 20. Can I get 20 from BEF? 3 out of these numbers, can it give me 20? No, it cannot give me 20, right? Because this total is 17, out of which I have to take out one number. So highest this can give me is 15, right? Highest of BEF will be 15. It cannot give me 20, right? Cannot give me 20. So 11 is not possible. If I take 13, I would need 18 from these three. Again, it is not going to be possible, right? Again, that is also not going to be possible, right? So A has to be 17. If A has to be 17, one of C or G will be 11. The other one will be 13. Right? Either case, the sum of these two will be 24. C and G will add up to 24. So once you get a hang of what are the numbers looking at, the first level over here was to identify, crack this set, crack the logic, what are the numbers being involved, right? Once you found the numbers which are involved, okay, all you need to do was look at multiple scenarios how one can play with each other. But still, you had to look at basic scenarios in mathematics, right? So it is not purely a logic based set, it is not purely a maths based set. You need maths over here, but you need to be able to apply maths here, right? Okay, so let's try another one. Okay, so this is the second set right now. Okay, again, I'll give you about 3 to 4 minutes to go through this set and see how this goes. Okay, let's see what the question said. Okay, this is slightly, it's not very difficult. It's a moderate level question, but you have to be very clear about where the cubes will be found. If you know where the cubes will be found and you can visualize it, you can answer this question pretty quickly. Okay, it's not a very difficult question. It's not a very easy question because it's not very common. Okay, now this says 729 identical red cubes are stacked into 27 identical cubes. So 729 is 27 square, so you'll have 27 into 27 pieces. So 3 into 3 into 3 will be a small piece of 27, right? Each of these cubes will be stacked into another set of 3 into 3 into 3, right? So this is how the cubes are done. So you have a small cube, right, which will be stacked into 3 cross 3 cross 3. So let's call it a medium cube, right? These 27 cubes are then stacked to form a large cube. So these 27 cubes, so there is one cube which has 27 cubes. There are 27 such cubes, right, which will be stacked together to form a large cube, right? Now this is red on all six surfaces. Then this one is painted blue, and then this is painted green. Okay, now just to make life easier, I have created this part over here, right? So this is stacked into this, and this is then stacked it on it. And now, before we jump into solving the questions, right, let's see what actually happens in a cube. Now, in a cube, only the external surface is going to be painted, right? So this cube, which has 6 red faces, they will be stacked to form a blue cube, right? How will you get a blue cube? You'll first stack 27 cubes here, right? And then you'll paint the external surface blue. Now we know when you paint a cube, you can get 3, 2, 1, or 0 surface painted, right? Which means the balance 6, 5, 4, and 3. These will still remain red, right? This will still remain red, right? All these cubes are stacked to form a large cube, right? Now, once you paint a surface, once you lose your color, you cannot get back to the red color again. So in the final cube, you'll still have 3, 4, 5, 6 as red, right? Because only the external surface of this cube will be painted, right? Only the external surface of the medium sized cube will be painted in the large cube. So the reds, which are not painted over, will still be safe. It's only the blues which will get affected. Only the blue surfaces will get painted over. Some of the blue surfaces, for example, here, will completely lose all their blue color. They will now be green, right? Some of the surfaces, some of the cube here, right? This will have two green surfaces exposed. So it will have two red colored surfaces. One on the face will have one red colored face, right? And one green colored face. One inside will still have all their blue colors and their red colors involved. So only the surfaces which are painted once will be painted over again, right? So the red colors which are not lost here will stay as it is, right? So that is one part. And only the surfaces which have been painted blue will qualify for the green color. If you bear this in mind, the questions are pretty straightforward to answer. Okay, let's go to the questions. Okay, I've just marked out this surface so that it's easier to calculate. How many of these 729 small cubes have red color on more than 3 faces? Right. Now, if we go back again, right, we know red color will be there on at least 3 faces. So you want more than 3 faces to have red color, right? In the medium sized cube, cubes which are on a corner will have 3 blue surfaces and 3 red surfaces, right? Except for these corner cubes, all the other cubes will have more than 3 red surfaces, right? So in a medium cube which has 27 cubes, take out the 8 corners. So we'll be left with 19 cubes. 19 pieces in one medium cubes. One medium cube. How many medium cubes are there? There are 27 medium cubes. So direct extrapolation. 19 into 27. 19 into sorry, 27 into 20 will be 540. Minus another 27 will give you 513. Right? That will be your answer. Right? So only the cubes which are lost are the ones on the corner. Right? Everything else will have more than 3 red surfaces. Right? So we can calculate them straight away. Let's go to the next one. How many of these 729 small cubes have no blue colored surface? Right? Okay. Now we know these blue colored surfaces are there. These cubes will have 3 blue colored surface, 2 blue colored surface, 1 blue colored surface, and 0 blue colored surface. Right? Okay. Now you want the three blue colored surface to lose all their blue colors, which means the corner cube should be present in the corner here also. Only then it will have 3 blue colored surface exposed and it will lose all the 3 to green. 2 surfaces, right? 2 surfaces for a edge is exposed on an edge. So an edge cube in a medium sized cube should also be present as an edge in the large sized cube, something like this, right? One surface is painted in a on the face. So a face cube here should also be a face cube here, right? And then you have the 0, which are internal, right? That is not bothered at all. So let's calculate all of them. Okay. 3 surfaces should all be green. Which are these? These are corner cubes of the medium cube, which are also in the corner of the large cube, right? Right. So there are 8 corners and you can fit only 1 cube in the 8 in each of the corner. So 1 into 8, that will be 8. 2 surfaces were blue and both those surfaces became green. So it has to be on the edge of the medium cube and it's also on the edge of the large cube. So let's count along the edge. Let's count along the edge. Right, let me just erase this to make life easier. Okay. Now, this is one such edge piece. This is the second edge piece. This is the third edge piece. So 3 on one edge. There are 12 edges in a cube. So 36 pieces. One face which was painted and it ended up getting painted here also. So face cube of a medium sized cube, which is also a face cube for the large cube. So you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on one face of a large cube. 6 such faces, 54. Are we done? No, we are not done. We also need to count this 0. Where will you get 0? 0 will be the core cube of the medium cube, right? There will be only one core in a 3 cross 3 cross 3. So 1 per medium sized cube. 27 medium sized cubes. That will be 27. This is the total number you require. 54 plus 36 is 90. 90 plus 8 is 98. 98 plus 27 is 125. Right? So you need to still know the geometry of a cube. You need to find where to find the piece which you're looking for. And then extrapolate. Corner, edge, face, core. Right? Let's go to the next one. How many of these small cubes have equal number of blue and green faces? Right? Now, if we go back to our original discussion, right? You know, there'll be at least 3 or more red faces, right? So you can have 3 red face, 4 red face, 5 red face, 6 red face, right? So you can have at most the number of blue surfaces will be less than or equal to 3. Number of green surfaces will be less than or equal to 3. Now, the only way to get them equal will be both of them should be 1. 2 is not possible because then you will be left with only 2 red face. That is not possible because each cube will have at least 3 red faces, right? 3 is also similarly not possible. So you need to look at one blue face and one green face. Now, if a face is painted on 2 surfaces in the medium cube, right? It can be painted only on 2 surfaces in the large cube, or it can be painted only on one surface in the large cube, or it may be painted in 0 surface, like the equivalent of somebody here, right? That will not have any surface painted. So you're looking at 2 faces which are painted, right, in the medium cube, right? And only the blue colored surfaces will be painted over, right? So let's look at 2 faces painted. 2 faces painted are edge. So we are looking at edge cubes of the medium cube, which are placed such that only one surface gets painted over. One surface painted over will be found on a face. So edge cubes of the medium cube, which are found on the face of the large cube. So let's see where we get this. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 such pieces, 24 such pieces on one face. 24 pieces on one face. How many faces? 6 faces. 144. That will be your answer. Remember, only the surfaces, look at our initial discussion. We discussed that only the faces which are painted blue are eligible to be painted green. You cannot have more than that painted green. So a face cube cannot have 3 faces painted green in the second stage of painting, right? In the final stage of painting, right? So we'll find the pieces here, edge pieces which will have only one face exposed, which means they will be on a face, right? Let's go to the last part of this. The last part says, how many of these 729 small cubes have 3 faces of one color, 2 faces of the second color, and 1 face of the third color, right? Right. Now, the 3 colored face would be red. So they have 3 red colored face, which means 3 faces were painted blue in this stage of painting. What are we looking at? We are looking at corner pieces, right? We are looking at corner pieces, right? Now, these corner pieces should lose 1 or 2 of their faces, but not all 3. So we don't need the corner piece here again, right? They should lose either one of their faces. If they lose one of their faces, for example, this cube here. If you look at this cube here, this is a corner cube, right? So in this stage, it will be probably placed here, right? If I stack it over here, this will have 3 faces painted after the first stage of painting. It will have 3 reds, 3 blues. When I paint it over here again, it has only one face exposed. So one of these blue will become green. So you'll have 2 blues, 1 green, right? So 3 of one color, 2 of one color, 1 of the third color. This is one such piece. The other such piece is where you lose 2 such faces, right? 2 faces exposed will be on an edge, right? So let's see where. This is a corner piece which is on the edge of the main piece, of the biggest piece, right? It'll have two additional surfaces exposed. So two will be painted green, one will still remain blue. So we already know how to proceed now, right? So let's look at it along an edge. One, two, three, four. Four pieces on an edge. There are 12 edges. So 48. Corner pieces which are on the face of the main, right? These are the pieces we are looking for. Four here, four here, four here, four here. 16 on one face. There are six such faces. So 96. Total will be 144. So these are the pieces that we are looking for, right? So this is not a question that you get normally, because you have questions normally where you have painting is done only once, right? But here the painted cube was painted over again and again and again. But we still had to work with our basics, right? We still had to work with our basics. We needed to find out which piece can be painted, where will we find the piece, right? The question is not difficult. The question is not difficult at all. All you need to look is, all you need to look at is make sure that you find where the pieces are done, right? Okay. So that finishes our sessions for today. I will request your feedback on these questions, right? Do let me know either on the video over here, or you can connect with me individually, right? We will do another such video very soon, and please do look at both the 2IIM courses as well as the Topmytest courses. Till we meet again, good night and have a nice day.